Hey guys, it's Vince, and today I'm really excited to discuss a project I've been working on for quite some time. I don't know of any other one of these in the industry. It's called the Accu-scale, and what it allows is for end users to calibrate their system at distances exceeding 1 inch. We've typically seen in the industry a limitation of only being able to use a dial indicator, which may be okay for a smaller length machine, but machines in excess of 4 feet, 8 feet, 10 feet, they want an actual calibration that's going to give them a scale percentage that they can work with and really extrapolate out any variances over distance. So what we have here, I have a past client of mine, Mike, and he has got his system all set up. He's got Pneumatic set up in this window. Over here we have the setup with the Accu-scale. You can see it's set right here. We're going to show you calibration done live, the first time ever, accurate to 5/10,000ths of an inch using the Accu-scale system. The unit uses 2 weighted bases. You can see the remote mounted DRO right here, and he will be able to now calibrate his system at 600 millimeters, and for my Imperial guys out there, that would translate to 24 inches. Now, of course, he's not going to go the full length. If he wanted to, or an end user wanted to, you could, of course, order a longer Accu-scale to cover virtually the entire length of the table, and you could calibrate to that specific length. So once again, this is really unheard of in the industry. The unit does have a built-in leveling system. The level is imported from the UK. You'll see that in the other video, but I don't want to waste any time here. We're going to get right to the meat and potatoes, and you guys are going to get to see this unit in action. It's pretty amazing. So first thing I want to point out is the probe on the unit is actually mounted into the end mill position. And the beauty of this means that no longer are you taking arbitrary measurements on the side of the spindle or on the side of the spindle mount where the plunger on the dial indicator always will be off-cocked due to the fact that it never hits in the exact same place. And of course, we all know if we're using a dial indicator that's precision, typically 1/1000th of an inch or greater, that when you have to go and reset that instrument, you have to manually press that button, and as soon as you touch it, it's never in the exact same location. Well, the beauty is Mike has got this DRO right here, and it's digital, and you can see it's completely separate from where the end mill is in the actual spindle. And once again, we're taking a measurement, and I can't emphasize this enough, from the actual spindle's location of where an end mill will be. So you're going to have the most accurate measurement. That combined with a 2-axis leveling system, you have unparalleled access to make sure that everything is going to be as square as possible as we do a length measurement. And the beauty is also that once he uses this digital DRO, he can switch on the fly from an imperial measurement to a metric measurement just by pressing a button and never disturbing any of his setup tools when he's taking his measuring, which means you're going to have an unparalleled accuracy, no longer dealing with 1-inch dial indicator where we're once again dealing with a magnetic base and how it's set up. So I'm going to let Mike go through here, and we're going to actually take a measurement and do an actual calibration in the positive direction on his x-axis. I'm going to cycle over real quick to show you Pneumatic screen. He's got everything set up here. He's got his distance length set at 22 inches. His feed rate is set at 20 IPM. And again, we don't want to go fast because we're doing a calibration. Once we actually dial in the calibration and you're happy with it, you can naturally dial in a higher speed to check that feed rate at the calibration you set, which is imperative. Again, you're going to find out a lot about your system quickly. Mike and I were discussing, we found some tolerance differences over a 22-inch length, which is completely normal because now we're seeing all the inaccuracies that a chassis at length will incorporate, such as machining differences, screw tolerances. All of this now comes into play regardless of the transmission, and of course if we're dealing with a ball screw transmission, those tolerances will be much tighter than if we deal with a rack and pinion. But I will say this, you will get to see in real time now exactly what we've got. So Mike, if you're ready, we can do that 22-inch measurement going to the positive side on the x-axis, and we'll show them exactly what we got here. Perfect. You can see the scale is measuring right now. He's running at 20 inches per minute. And once again, I can't emphasize enough, you can see the probe on the Accu-scale is mounted in the end mill position, giving him, once again, the best accuracy you can have because you cannot simulate anything closer to that. Now, we actually came up with a method because Mike ran into an issue where we wanted to make sure that we could fit a multitude of different spindle collets. We use a little heat shrink as a buffer in terms of a spacer so that his collet would work. I will include that, of course, in the Accu-scale finished product, but you can see her right now measuring in millimeters. Now, this is interesting for you guys out there who are using Imperial. Mike is using Imperial, but I had him switch over to the metric system when actually doing this, and the reason we're doing it, we could see the tolerances much easier. A lot of guys are not familiar with reading a DRO down to 5/10,000ths of an inch. You'll hear guys say it all over the place, you know, it's 700ths off or this, that off. This we get to actually break down into the metric system, and we do it on the fly. And you can see it stopped right now at 558.75 millimeters. I believe I'm correct. Am I correct, Mike? Okay. 558.75 translates to 21.998 inches. So he is exactly 2/1000ths of an inch off, running at 22 inches width on his chassis. Now, what does that mean to the end user? Well, it means this. Mike, your chassis is how wide? 48 inches. So we're 4 feet wide, and he just did basically half of the width of the chassis. And you can see we still have a little room here on the scale. Had he decided to go 24 inches, he could have. But here I want to paint a pretty picture to guys out there wondering how accurate their machine is. If you take a measurement at 1 inch, you're only getting a variable of 1 inch per 48 inches, which means you're going to have to extrapolate that variable. In this case, the variable is 2/1000ths of an inch. You would have to extrapolate that if that example is taken at 1 inch up to 48 times because you've only measured 1 inch. In this instance, to show just how accurate this now has become, being he's basically covered the half of the length of the machine width-wise, you would only multiply that generally by 2. So he'd only be 4/1000ths off per 4-foot width, or 48 inches, pending, of course, this tool is 600 millimeters in length, also known in imperial terms of 24 inches. This is amazing if you think about it. We were never able to do this before what's currently on the market, and the beauty is, if you notice, Mike has got all this information right here, all set with the DRO, and at any point in time, he can cycle between. Go ahead, Mike, show him how easy it is to cycle between imperial and metric on the fly. Boom, just that easy. And he didn't disturb any of his tooling. He didn't disturb anything. The tool is measuring exactly the same. We could scroll, hit it again, Mike, go right back to metric. Boom. And there you go. Now my guys that are doing imperial and doing metric both have both variations. Let's send her back home, Mike, to 0 and see where we are in tolerance. Now, mind you guys, of course, he's doing this at 22 inches of length, but that's completely arbitrary. If he decided to check a 10-inch travel backwards, he could do that. If he wanted to check 3 inches, he could do that. You will find tolerances that you don't normally see. Mike and I both covered that. It was interesting. We used a 1-inch dial indicator, and all of a sudden we have perfect at 1 inch like nothing. As soon as we do 22 inches, you're going to find those tolerances are going to be really true when we use a tool like this, because, again, all those hidden discrepancies with machining, once again, screw tolerances, and just inevitable variables are now coming to fruition. So, again, it's very, very interesting. Whenever he's ready, you go for it, Mike. Okay. Okay. Yeah, you could put in, let's do it, we'll do a regular calibration. Let's put in 21.9980315. 21.9980315. Now, once again, guys, what we just did right there is by putting in, again, the numbers in an increased amount of decimal points, what you're going to find is the accuracy will be that much greater. The more decimals you go, the greater the accuracy, because, again, your CPU is a math coprocessor, and it's going to break down the math so we can get that measurement as close as possible. Okay, that's fine. Yeah, you can run it just backwards. I know exactly what you're doing. That's perfect. Right on. And again, you can see his speed. He's running now at 20 inches a minute. It's very smooth. And I'm telling you guys, if you're buying a system from an actual manufacturer, any claims that these manufacturers have, you're going to be able to see very quickly. If they're telling you your machine's supposed to be accurate at a certain length, you can calibrate the machine and see where you're at. Where do you actually fall? I think it's very difficult for manufacturers to claim that because every machine is not machined perfectly. So to say that, it's kind of like, well, Mike's a helicopter pilot. It's kind of like saying every chopper, even though it's the same type, flies the exact same. They all have different trims and balances due to the fact there's variables. And these are things that we have to remember with robotics. And this is very interesting. Once again, to see this done live, I've never seen it done, and I was excited to get with Mike to do this. He volunteered, and again, it's just a great privilege to do this live for you guys to see it. She's almost there right now. That's amazing. We are at 5 thousandths, I believe, or 500. No, I'm sorry, 0.005 millimeters, or 0.05 millimeters. No, it doesn't matter. We'll leave it at millimeters so we could stay as accurate as possible. It's 0.005. Am I correct, Mike? 0.05. You're at 1,000th of an inch, and this man just traveled exactly 22 inches. So you can see on the opposite end, he was I believe 2 thousandths or 3 thousandths off on 22, and on 0, he was 1,000th of an inch off of actually automating 22-inch span. That is absolutely amazing. He knows that his tolerance will be slightly off it's just invariable of the machine, but once again, we've already covered it, and for most end users, himself included, for his application, now he knows he's safe in that the measurements are correct, and he's ready to measure again at any point in time. And once again, Mike, show him how you switch it to imperial. Right there, and now he knows exactly where he is, and right now I believe it's registering 2,000th of an inch. And I've got right now, if we do a Google breakdown on that, we are at 0.0019, so there it's rounding up to 2 thousandths, and you can see exactly how we work. So again, guys, I'm going to cut over into the other video. Please leave your support for Mike. It was great of him to put his time forth to do this and show everybody this. It's imperative you guys see it, and now I'll cut into the other portion of the video. Okay, guys, I want to give you guys just a quick breakdown of something that was never able to be achieved before either. And this is Mike running a calibration. What is the IPM set at, Mike? Is it 100? 80. It's at 80. So we're going to run at 80 inches a minute. And you can see the DRO here. And he's going to track at 22 inches what his actual accuracy is at that speed. This is something we've never seen before because the only thing you could do is hit it 1 inch. So you were never able to check your rapids. And of course you can dial in your speeds now for optimal tuning, whether you're using a stepper or a servo, at a ratio that is unheard of. So Mike, I'll let you take it away and we'll run it and we'll show him exactly what we got right now. She's at 0. You can see the DRO here, and we'll just do this real quick run and see what we get. Once again, we see the DRO moving. And right now, we are at 219.99. Is that imperial, Mike, or is that metric? There we go. And you could switch over, just hit the button. Yeah. And you can switch over to metric. We'll just show them what we are. And there you go. We're at 558.79 metric. And then if he wants to switch to imperial again, go for it, Mike. It doesn't get any easier than that, gentlemen. It's that simple. He never touched anything. That is absolutely amazing at that rapid. And he's done it at distance, which no one has done. We're going to go back down to 0 now, and we'll see exactly where we go. Just leave that DRO the way it is, Mike, and we'll go back the other direction. Perfect. There we go, guys. So once again, I hope that this video has been enlightening. Once again, I want to thank Mike for his time and his robot. This is a really amazing thing to see in action. Once again, I've worked long and hard on this, and I hope it helps many of you. Thank you again. Take care.